Now let us look at the next problem. Two solid cylinders P and Q of same mass and same radius start rolling down a fixed inclined plane from the same height at the same time. Cylinder P has most of its mass concentrated near its surface, while Q has most of its mass concentrated near the axis. Now which statements are correct? Okay, now let us try to understand the situation. Let's say this is a cylinder having moment of inertia about center of mass being ICM, and since this is rolling down without slipping at point O, if we wish to find out moment of inertia, that would be equal to ICM plus mr square, okay, from parallel axis theorem. Now if we find out angular acceleration alpha of the center of mass with respect to point O, then the torque will be given by I into alpha, which is equal to the perpendicular force mg sine theta, and perpendicular distance is r. Okay, this distance is r. So the value of alpha will be equal to mg sine theta times r upon I, where I is ICM plus mr square. Okay, so acceleration of center of mass, which is equal to alpha times r, will now be equal to mg sine theta r square upon ICM plus mr square. Okay, now the moment of inertia, if we wish to compare for the two cylinders P and Q, it is given that in case of cylinder P has mass m and more mass is concentrated near the axis of the cylinder. I'm sorry, it is other way around. More mass is concentrated towards the surface, and in Q more mass is concentrated towards the axis. Okay, so if more mass is distributed or more mass exists away from the axis of rotation, moment of inertia is more, because moment of inertia is directly proportional to r square. If more mass is at a larger distance, moment of inertia will definitely be more. The moment of inertia of P will be more than moment of inertia of Q. Now if we look at acceleration is inversely proportional to some, it is mg sine theta times r square upon I plus mr square. So the value of I is more, the value of A will be less. So acceleration of P will be less acceleration of Q. Okay, which basically means that if the acceleration of P is less, that means it will take more time in reaching the base of the incline, and Q will take lesser time because acceleration is more. So if you look at option A, both cylinders P and Q reach the ground at same time, is incorrect. Cylinder P has larger linear acceleration than cylinder Q. This is also incorrect. It is other way around. Okay. Now option C is both cylinders reach the ground with same translational kinetic energy. Now that we have to understand. And option D is cylinder Q reaches the ground with larger angular speed. Now let us say we have the cylinder initially here and the omega was 0 because it started from rest and kept rolling and came down towards the level ground, and by that time it has got its angular speed as omega. Now the difference in the position of the center of mass in terms of height is h. Okay, so the potential energy that has come down is equal to mgh, and this decrement in potential energy has increased its kinetic energy. Now this kinetic energy is in two forms. One is translational, another is rotational. Okay, now translational kinetic energy will be given by half mv cm square, that is center of mass velocity, plus half I cm omega square. Okay, now in both the cases the drop in potential energy mgh is same, and that will be equal to the total kinetic energy. That means sum total of translational kinetic energy and rotational kinetic energy. If you add both of them, they will be same, but if you compare the translational kinetic energy, that will be definitely less. Now let us see how. We know that the value of omega can be written as vcm by r. Okay, now if you substitute this value here, we will get half m vcm square plus half icm plus omega, that means vcm square by r square. Now if we add both of them, we will get half m vcm square plus half I upon r square vcm square. Now if we multiply by m and divide by m this term, we will get half m vcm square as common, 1 plus I upon mr square. This is the total energy, which is equal to mgh, and this term is translational kinetic energy. The kinetic energy translational will be given by mgh upon 1 plus I upon mr square. Now since the value of I is different in both p and q, okay, it is actually more in case of p as compared to q, therefore the kinetic energy of p will be less as compared to q. This we are talking only of translation kinetic energy, so it cannot be seen. So option C is also option C, that is both cylinders reach the ground with same translation kinetic energy, is wrong. So option D has to be correct because the other three are incorrect. Now let us see how this is correct. Now we have just found out that the velocity of center of mass is a function of something upon 1 plus I upon mr square with under root. Okay, because if we put the value of here kinetic energy as half vcm square, we'll get the value of vcm as under root of 2gh upon 1 plus I upon mr square. So we know that the velocity of center of mass of P will be less as compared to Q because moment of inertia of P is more than moment of inertia of Q. And if this is the case, then omega of P upon reaching the ground will be lesser than omega of Q. Okay, so option D, cylinder Q reaches the ground with larger angular speed, is correct.